Hi everyone, today we are going to study students class 11 topic, that is heat transfer. Now let's first understand what is the name of topic. So first term is students heat. Now let's understand what is heat. Now heat is a special form of energy, right? Heat is a energy, but it is special because heat only transferred from one body to other body only when there is a temperature difference. So suppose there is a body A and there is a body B. Temperature of body A is TA and temperature of body B is TB. Now suppose temperature of A is more than temperature of B. Then students, if A and B are put into contact, then heat will transfer from A to B. Why from A to B? Because high value of temperature indicates that A has high value of energy. So heat will transfer from A to B, right? And second term in this topic is transfer. So in this topic we are going to study modes of heat transfer. In how many ways we can transfer heat from one body to other body, and on which factors heat transfer depends. So students, we are going to study three modes of heat transfer in this case. So first one is students, our conduction. First mode of heat transfer is conduction. Second one is our radiation, or you can call it convection also. And third one is students, radiation. Now students, let's first understand what is conduction. Now let's understand this by a simple example. So suppose you might have done this experiment. Suppose you are holding one end of a spoon and you are heating the other end. Okay. Now after some time you will feel that since you are heating this end, not this end, after some time you feel that this end, the end you are holding, also gets warmer. Now this end gets warmer, it means that heat transferred from this end to this end, right? Now let's understand that on a molecular level how this heat got transferred. So this is a solid. Now solid is composed of molecules. So students, when we are giving heat, it means that we are giving it energy. So on gaining energy, molecules of solid start vibrating more vigorously about their main positions. Now these vibrations are caused to our neighboring molecules via collisions. So similarly, this molecule will transfer energy to other particle, neighboring particle via collision, and similarly heat is transferred from this end to that end, and heat you will feel warm. Okay, because heat is transferred from this end to other end. Now important thing to note is that in this case our molecules of solid are not leaving their main positions. They are vibrating vigorously about their main positions, but they are not leaving their main positions. So in conduction, molecules do not leave their main positions, right? Molecules stay as it is. Okay. Now second one is convection. Now let's understand convection also by a very good example. So suppose you are boiling a water. Okay. Now you are heating at the bottom. Now what happens that you will notice that after some time whole liquid gets formed. So it means that heat is transferred from this lower into all over the liquid. Now how this happens? You might also notice that there are bubbles forming. Now how these bubbles are formed? Now students, when suppose you are heating this, our water molecule at the bottom gets more heat, so it gets students expanded, so its density becomes lesser than its surrounding, so it goes upward, and molecule which is colder compared to this one which is heavier compared to this one comes down, and then again it gets heated up, and again it goes up. So it means that there is a cycle formed. So colder molecules come down to get heat, and then they go upward. Now this cycle is called convection cycle. This cycle is called convection cycle. Okay. So in this way, whole our liquid gets heated up. Now important difference between conduction and convection is that in conductions molecules were not leaving their main position, but in convection molecules are leaving their main position. Now similarity between these two is that both require medium for transportation of heat. Now last one is radiation. Now radiation is a special form of heat transfer in which students we do not require any medium for heat transportation. For example, students, sun, this is suppose our sun and this is our earth. Okay, now there is no medium between sun and earth, but still radiation from sun reaches earth. Now this radiation has form of EM waves, electromagnetic waves, and we know that electromagnetic waves do not require any medium for propagation of energy. So it means that heat is transferred without requirement of any medium. Okay, so radiation do not require any medium for its transportation because it transmits energy in form of electromagnetic waves. That is the difference between conduction, convection, and radiation. Okay. Now students, we do not have convection in our syllabus, so we are going to study conduction and radiation. Now first topic we are going to study is conduction. Now, what is conduction? We already know that what is conduction. Now we need to study important terminologies related to our conduction. Now first important term is our steady state. Now what is steady state? Now suppose if we are heating a rod, now at some stage we notice that suppose we are heating this end. Now temperature at any point students becomes constant. Okay, because if there is an output of heat, right, heat can be taken out of the material, then after some point students, after some time temperature at any point becomes constant. Suppose here temperature is, suppose it is 50 degrees Celsius, suppose here is 40 degrees Celsius, etc, etc. So at this point temperature will not change with time. Although temperature here is 50, although temperature here is 40, so temperature at this point will also be 40. Okay, it will also not change with time. So it means that in steady state temperature of different points on rod will become constant. They will not become same, but they will not change with time. Okay. Now students, why that is not changing with time? It means that suppose if this point was accepting net heat, then temperature of this point would have been increasing. Now if this point was rejecting net heat, then temperature of this point would have been decreasing. But since it is constant, it means that the amount of heat it is accepting, that incoming heat should be equal to the amount of heat that is outgoing, that it is rejecting. So in steady state, incoming heat is equal to outgoing heat. This is very important point, and we are going to use this point. Steady state, incoming heat is equal to outgoing heat. Okay, body will not absorb any more heat. Now all laws of our conduction are applied on steady state. So you might also need to note this point that all laws of conduction are applied on steady state. Okay. Now next very important topic is our students isothermal surface. Isothermal surface. Now what is isothermal surface? Now let's understand rod. Okay, in a three-dimensional way. Suppose this is our rod. Now students, notice that suppose heat is transferred from this end to other. Now perpendicular to heat transfer there is a surface. You might notice that this is for a square cross section. On this surface friends, temperature at every point becomes same, right? It means that on this surface temperature at every point is same regardless of the position. Now this surface is called isothermal surface. Isothermal means that temperature same. Now important thing to notice that isothermal surface is located perpendicular to direction of our heat flow. So you might also note this point that isothermal surface is located perpendicular to direction of heat flow, and on this surface heat transfers, on this surface temperature is constant. Okay, it does not vary. Now third important term related to our conduction is students temperature gradient. Temperature gradient. You might have heard term gradient, right? In maths and in other topics also. Now what is gradient? Something divided by length. Change in something divided by length is called gradient. Now here there is term temperature gradient. So change in temperature divided by length is temperature gradient. Now how to define this temperature gradient? So let's again take example of the rod. Okay. Let's again take example of the rod. Now let's take two isothermal surfaces. Suppose this one is our first isothermal surface and this one is our next isothermal surface. Now suppose heat is flowing from this end to this end. Now suppose here x coordinate is x and here x coordinate is x plus ds. Since indirect heat flows from high temperature to lower temperature, so suppose temperature here is theta, then temperature here will be lower than theta, that will be theta minus d theta. So temperature gradient will be change in temperature divided by change in length, change in x coordinate will be, friends, here change in temperature is theta minus d theta and initial is theta, and change in x coordinate is x plus dx minus x. So this will be minus d theta by dx. Notice that here minus sign indicates that actually in direction of our heat flow temperature decreases. So this is our temperature gradient, right? Very important term. Okay, temperature gradient. Now for average value you can also write minus delta theta by delta x also for average value. Okay, this is for average value. This is for our average value. Okay. Now students, let's study our law of conduction, that is called Newton's law of conduction. So students, please put down the heading Newton's law of conduction. Newton's law of conduction. Now what is Newton's law of conduction? Now Newton said that rate of heat flow, notice that it is not the heat, it is rate of heat flow. So Newton said that rate of heat flow depends, first thing is, students, suppose we are using a rod, okay, we are using a rod to transfer heat, okay, by conduction. Now suppose this area is A, area of isothermal surface or area of cross section is A. It is transferred from this end to this end. Okay. Now suppose let's take temperature at theta and this will be theta minus d theta to define temperature gradient. Okay. So dq by dt, rate of heat flow, depends on, students, first is our area of isothermal surface, that is A, and second one is, students, our temperature gradient. Higher the temperature gradient, high will be the value of rate of heat flow. Now if we combine these two values, students, we get dq by dt as proportional to minus a d theta by dt. Now students, if we remove proportionality, we have to apply a constant. Now dq by dt will be equal to ka, sorry, this should be here, ka minus d theta by dx. Now this is for the instantaneous rate of heat flow. For average value of heat flow, you can write that delta q by delta t is ka minus delta theta by delta x. Okay, this is, friends, our rate of heat flow. Now there is another way to visualize this rate of heat flow. For example, just like current flows because of potential difference. Electric current is rate of, students, potential difference divided by resistance. Now students, this is, can be visualized as heat current. Just like electric current is rate of flow of charge, heat current is rate of flow of heat. So this can be written as IH, right? Now delta x is our change in x, that is length, right? So IH can be written as, friends, suppose temperature difference, I am writing magnitude of temperature difference, that is delta theta, upon, students, delta x I am writing as L. Okay, L by V. Just like, students, current was V by R. Here, in place of potential difference, we are writing temperature difference. So this quantity is equivalent to this quantity. This is our resistance. So this is called our thermal resistance, opposition to heat flow. So our thermal is L by Ka. Now this analogy is very useful. In most of the cases, students, we use this analogy because this is very useful while solving the problems. Okay. Now this constant K is called, students, conductivity of material. Now students, this conductivity, notice that suppose we are taking two rods, one is made of wood and other is made of, students, steel. Suppose they have same value temperature difference, same delta X, same. So you might notice that, students, rate of heat transfer through steel will be much larger than rate of heat flow through wood. What is the difference? Difference there is of K, right? Value of K for steel is much larger than wood. Okay, so it means that K depends on material. It is property of material. That's why it is written as conductivity of material. So thermal conductivity of metal is much larger than the non-conductive materials. For example, silver has the highest value of thermal conductivity as well as the electrical conductivity also. Now students, let's solve some questions on our conduction. Okay, let's begin with very easy question. So suppose you are given a rod. Suppose this end has temperature 100 degrees Celsius and this end has temperature, students, 10 degrees Celsius. Now this is a meter rod. So suppose length is 100 centimeter. Okay, you are to find temperature at 20 centimeter from the hotter end. Suppose temperature is T, you have to find this. Okay, now students, there are two ways to solve this. First one is that this is talking about steady state. So it means that incoming heat or heat flowing through this part, left part, should be equal to outgoing heat. It means that heat current flowing through right part. So incoming heat current should be equal to outgoing heat current. Now heat current is temperature difference by thermal resistance, or I is Ka delta theta by delta x. Delta x is nothing but length. Delta theta is temperature difference. I am just going to write, students, magnitude of temperature difference. So in this case, high value is 100 and lower value is T. So temperature difference is 100 minus T into, students, notice that rod has uniform area and made of same material. So K will be same and area of cross section is also same. Now length of left part is 20 centimeter. So length of right part will be 80 centimeter. And here Ka, temperature difference will be T minus 10 upon 80. So what is that? 20 and this 4 cancels out, this K cancels out. So 4 gets cross multiplied. So this will be 400 minus 4T. This will be equal to T minus 10. So this will be, students, 410. This should be equal to 5T. Right? 410. This should be equal to 5T. So T will be 410 by 5. 5 8 are 40 and 5 2 is 10. Okay. So this will be 82 degrees Celsius. Now, students, this heat flow, another way is that suppose this heat is, students, going through whole rod. So this can be written as, students, this term can be made equivalent to, suppose heat current through left part was Ka 100 minus T by length was, students, 20 centimeter. Now, this is same as heat current flowing through whole rod. Now, for whole rod, this is 100 degrees Celsius, this is 10 degrees Celsius. Length is 100 centimeter. Okay. So, for whole rod, students, heat current flowing will be Ka, temperature difference is 100 minus 10 by length is, students, 100 centimeter. So, 25 is 100 and Ka cancels out. So, this will be 500 minus 5T. This will be, students, 90. So 5T will be 410. So again, students, temperature will be 82 degrees Celsius. Okay. There is another way to visualize it. So this is our first question. Let's improve, students, the difficulty level. So instead of taking one rod, let's take 3 rods. Okay. Let's take 3 rods like this. Now students, all rods are made of same materials. They are identical in every shape and size. Okay, it means that their length is same, area of cross section is same, and they are made of same material. Made of same material means that thermal conductivity is same. Okay, this is also LAK, this is also LAK. Now here suppose temperature is 100 degrees Celsius, here temperature is 80 degrees Celsius, and here temperature is 10 degrees Celsius. Now suppose you have to find temperature at the junction. What is the junction temperature? Now notice that friends, let's solve this problem via heat current concept. So since our thermal resistance was L by K, since L, K all are same for rods, means the thermal resistance must be same. So notice that heat always flows from high temperature to low temperature. So suppose this is the I1 heat current and this is the I2 heat current. Both are coming to junction. So incoming heat must be equal to outgoing heat in steady state. Suppose outgoing heat current is I3. Now I1 will be temperature difference by resistance, thermal resistance. So high temperature is 100 and low temperature, there is temperature at junction is T. 100 minus T by R. I2 will be 80 minus T by R and I3 will be T minus 10 by R. Now students, let's put the values. So I1 plus I2, because incoming heat current is I1 plus I2 and outgoing heat current is I3. So I1 plus I2 must be equal to I3. So when you put the values 100 minus T by R plus 80 minus T by R, this must be equal to T minus 10 by R. So R cancels out. So this will be students 180 minus 2T. This will be T minus 10. So 3T will be 190. So T will be 190 by 3. So this will be the junction temperature. Okay. Now students, let's solve another problem. Okay. In this case, we are taking students, suppose two rods which are joined in series like this. Okay. In some cases, friends, suppose here temperature is 100 degrees Celsius and here temperature is 0 degrees Celsius. Now, suppose this rod has length L, thermal conductivity K, area cross section. Now, this rod has length, friends, L, thermal conductivity is 2K and area cross section F. Now, again, you have to find temperature at junction. Okay. Now, again, you can apply same formula. Okay. Incoming heat current is equal to outgoing heat current. Incoming heat current will be Ka, students, 100 minus T by L. 100 minus T by L. And outgoing heat current will be, students, here K is 2K into T minus 0 by L. Now students, you can solve this by this. In some cases, students, they can ask what is the equivalent thermal conductivity of the case. Okay. They can ask what is the equivalent thermal conductivity. It means that if these two rods are replaced by single rod, now single rod will have students length L plus L is 2L, area of cross section will be A, and thermal conductivity is suppose K equivalent. Now they can ask what is the value of K equivalent. Okay. So for that, students, notice that equivalent rod means that amount of heat transferred through this combination should be equal to amount of heat transferred by this rod by itself. So it means that thermal resistance provided by these two rods should be equal to thermal resistance provided by this rod itself. So it means that thermal resistance in both the cases should be same. Now just like electrical resistance, these rods are connected in series. So their thermal resistance will be in series. We know that R equivalent is R1 plus R2. So for this rod, R1 is L by K, and for this rod, it is also L by 2K. This is our thermal length. And for this rod, students, R equivalent calculated as length is 2L by K equivalent into A. So both should be same because system is identical. So this should be, when you add these two, this should be 3L by 2KA. And this should be equivalent to, students, 2L by K equivalent into A. Okay. So here, students, L cancels out, Ka also cancels out. So it means that K equivalent will be 4K by 3. Okay. K equivalent is 4K by 3. I am giving you one homework. Suppose instead of being connected in series, they are connected in parallel. Okay. LKA. And this is L into, students, this is suppose different one. L into 2K into A. Now you have to replace them by single rod. Now single rod and you will hit single rod will be twice as wide, means the area of cross section will be 2a, and here students depth will be L and equivalent thermal conductivity is K equivalent. You have to find K equivalent. Okay. Now you know the process. You just need to students apply parallel combination rule here, because here rods are connected in parallel, and equate them with this one. So you can find out your equivalent thermal conductivity. Okay. So I hope you understood the lecture well. Thank you very much for listening.